this is a conductivity test. We're going to test whether or not a solution of a given substance conducts electrical current. And to do this, we have this very sophisticated conductivity test meter, which is a 6-volt lamp battery, some wires, some little bare ends of the wires, and hooked into the circuit is an LED. Do you know what LED stands for? How many of you have heard the term LED? You have LED Christmas lights at home? Okay. Light emitting diode. It's a neat little piece of gadgetry that you put into a circuit, and every time current passes through it in a specified direction, it lights up and emits light. So if I just connect those two wires down here and close the circuit, hey, what do you know? It lights up. And I can unconnect them. So we've got our very sophisticated testing apparatus, as I mentioned. And the first solution we have is calcium chloride. Try to get that on camera. Dark. Oh, come on. Is it lighting? Yeah. Okay. Nicely lit. So we would say that calcium chloride is a conductive solution. Oh yeah, I see it now. Okay, so we'll give our electrodes a quick dry off. So we'll set calcium chloride aside. Give those a quick dry as I break my sophisticated, high-tech, expensive solubility or conductivity apparatus. Okay, so this is our sucrose solution, and we put the lights in there and we get nothing. Nada. Big fat zero. So sucrose would be considered non-conductive. This is our potassium iodide. And we get a nice light up on that, I believe. Oh yes. Lovely little light up. Nice. Nicely lit.
Pardon the interruption. At this time, I need the following students to report to the area in front of the auditorium doors. Alexis Ballerstein, Katie Cook, Taylor Easton,
So we have our citric
Alexander
acid.
Eisenhart, Emily Ludwig, Claire Meredith,
I'm going to stick that
Ashley
in there.
Milhone, Ella Poland, Emma Shemazik, and Rachel Smith. Please report to the area in front of the auditorium doors at this time. Thank you.
This is the citric acid. Now, citric acid should not be conductive. I have a feeling we might have cross-contaminated. We're getting a brief flicker of, looks like it's flickering on and off. Is that what you're seeing? Yeah, so we're getting a little bit of conduction, but it's not overall very conductive. You can even put partial if you want. You know, it's somewhat conductive. Here's our sodium chloride solution. This is a good old table salt solution. And this one should light up like a Christmas tree. Oh yes. Very nice and bright. So I can get a better perspective on the bulb. Yeah. Very bright. Okay. And then our final solution is the phenyl salicylate. Now, based on how phenyl salicylate behaved in water, would you even call that a solution? No, it's not even dissolved. So this is kind of just like a good joke. Nothing, which we knew. Okay, so I'm going to tell you this. How many of you have been told not to swim when there's a lightning storm? Don't swim in lightning. Water's conductive. You'll get fried. I'm going to tell you this. If you want to go out and swim in a lake of distilled water and shake your fist at the sky and laugh, ha ha ha, you can't get me, you go right ahead. Because distilled water is non-conductive. Pure water is non-conductive. Now, lakes, rivers, streams, ponds are nothing like pure water. They got all kinds of other stuff in them. Fish pee, goose poop, runoff from the land, all kinds of things. And different chemicals in solution have different levels of solubility. So we got 3 here that seem to be soluble, or I'm sorry, that seem to be conductive, and 3 that are not. Well, one of those 3 is like, you get little bits of current through. Many years ago, I worked for the Division of Wildlife, Department of Fisheries. And we used to do what we called electro night fishing. And electro night fishing is really cool because you go out on a boat at night, as the name would imply, and on the front of that boat is a boom. It's basically a long aluminum pole that sticks out about 10 feet over the water. And hanging on the end of that boom are 2 aluminum rings, big rings, like, 1.5 feet across, that form a figure 8, and they clamp onto the end of the boom. And then clamped to those rings are a series of like monster alligator clips with wires leading down to big chunks of aluminum. It's quite an outfit. And on the front of the boat is some poor sucker, usually it's the $8 an hour summer help, that'd be me, who stands there with their foot on a pedal, and as long as your foot is on that pedal, current is passing through that boom, through those figure 8s, down those wires, and into the water. And it's creating an electrical field in the water. Now, who here has ever been shocked by an electric fence, or a cord without insulation, or something else? What happens to your muscles at that point?
They freeze up.
Yeah, they clench. Well, when fish swim in to the area of current, their muscles clench up and they float up to the surface. They lock up. And then that same poor sucker who's standing there with their foot on the pedal has a long-handled net and scoops up the fish, puts them in a big container on the boat, weighs and measures them, takes a scale sample, does whatever. Electro night fishing. Now, every night before we would go out, the biologist, I was a grunt summer helper. I was nobody. The biologist was the master's degree biologist who worked for the division, would go out and would do a Secchi disc test, which is a test of seeing how far down in the water you can see a marked disc. So you're looking at visibility. And based on the Secchi disc reading, he would tell us how many electrodes to hang off the rings. Because different levels of particulates in the water mean that it is more or less conductive. The more particulates you have in that water, the more conductive it is, the fewer electrodes you need. Very, very clear water with low particulate counts is not nearly as conductive. And so that's what they were looking at. Now, did we have sucrose in Atwood Lake? Did we have, who knows? Do we have phenyl salicylate? Probably not. But, fish pee is salty, goose poop is salty, salt running off the land is salty. So you've got lots of different kinds of compounds. You've got potassium and chloride and sodium compounds. So that's the solubility piece. Let's talk about the first 2 questions in your lab. So when it says to group them into 2 groups based on their properties, you are only grouping into 2 groups, and you must consider all 4 of the properties you tested. So what are the 4 properties you tested? Melting point, high or low. Basically, will this thing melt at a temperature we can generate with a candle or not? Solubility in water. Solubility in ethanol. And our last property was conductivity. So you need to consider all 4 of those, and you're just going to say, group 1, these 3. This is like which of these things is not like the other. For each of these, you're looking at relationships. You're not going to say anything about them, just group 1, group 2. For the next one, you're going to look at your group 1 and your group 2 and say, okay, these are their characteristics, either high or low melting point, either soluble or insoluble in water. And so based on that, you're going to list the characteristics of those 2 groups. The next 2 questions, I'm not going to say